Hi everyone, today this video will introduce you WEDAPT v4, the latest version of the immunogenicity prediction function in WeMol. WEDAPT is an immunogenicity prediction tool based on multi-model fusion architecture. This approach organically combined multiple models related to immunogenicity to form an efficient immune response simulation system, which can accurately simulate the immunogenicity of proteins, antibodies, peptides, vaccines, and other biopharmaceuticals, and identifies potentially immunogenic T-cell epitopes. Performance testing of this function showed a correlation of R equals 0.87 between the predicted score in mol score and the incidence of a DA. We can go directly into the WeSeq sequence editor to do this, operating with the antibody molecule bacasizumab as an example. After importing the sequence, click on the icon Immunogenicity. The latest version of WEDAPT v4 is recommended. Then click Calculate on the panel to perform the calculation. The calculations were complete a few minutes later. We can see that the immunogenicity prediction panel gives the molecule an immunogenicity score of 0.42, which is predicted to be high immunogenicity. Fractional distribution of reference. The blue dashed line marks the distribution of scores for the predicted molecule. It can be seen from the graph that bacasizumab's score has deviated from the 0 to 0.2 range, where most low DA molecules are located. Indicates bacasizumab a high-risk molecule. Click on the name of the molecule. Go to the molecular results detail page. In addition to the molecular scoring and score distribution charts, there is a table of epitope score. We start by introducing the contents of the form. Name of the chain where the epitope is located. Epitope N-terminal residue number. Epitope C-terminal residue number. Epitope sequence, which can be viewed directly on the sequence. Scoring of the table position of the paragraph. Number of activatable MHC isoforms. Specific MHC subtypes. Clinical molecules with identical epitopes present and their ADIA data. Human fragment search. Human fragments close to the epitope are recommended for de-immunogenic modification. Based on the results, it can be seen that the sequence at 47 to 61 on the heavy chain of the antibody has a relatively high-scoring epitope. We can modify this sequence by de-immunization design. First, number the antibody sequences. You can see that all three epitopes are on the CDR region. The simplest way to de-immunogenicity is to perform substitution of human fragments. Click on BLAST to access the Human Fragment BLAST interface. The tool splits the heavy chain of epitopes into 9 peptide fragments. Clicking on BLAST will allow you to perform a direct search for human fragment. Multiple clips can be retrieved at the same time. After the search is complete, first 25 homologous replaceable fragments are listed in the table. Mousing over homologous fragments will give specific mutation information. Click on Generate Related button to generate mutant sequences by fragment substitution. Click on the star button for epitope-specific mutations. Select the mutated 20 heavy chain sequences. Carry out immunogenicity calculations directly. At the end of the calculation, predictive data for the top 20 mutants are stored under the new molecular files. In the epitope score table, each mutant predicted epitope and its corresponding scoring data are given. We can access the job center via View Job, sorting the scores in the TC score table. Mutant selection rules. First, low immunogenicity score. Second, sequence and structural changes are relatively minor compared to the original. Immunogenicity calculations also give heat maps data, which can be downloaded and viewed. That's it for this video. If you like this video, please leave like, subscribe, and shared. Thank you for your support and welcome to WeMol.